Hello, this is Edmund Good, and I'm presenting input validation. What is input validation? Well, basically, it's also known as data validation. It's the process of inspecting and or testing supply data to ensure it's valid. Data can come from many different sources, like users or other applications, and this can be related to the old programmer's adage of GIGO, which is garbage in, garbage out, except the garbage in question are intended attacks. This links to the code review touchpoint in software security in that input is affecting the code response. And validation must be done whenever data passes through the boundary of trusted to less trusted areas. The main validation strategies are syntactic validation, which enforces correct syntax, such as making sure that characters are provided for character responses instead of integer response. And input is in the correct format for what is needed so that you're not putting in birth date of month, year, and day, or month, day, and year when you're actually looking at having year, month, and day. Then semantic validation enforces specific business context value correctness. Basically, what that means is it's basically checking to see if that the response makes sense in the business model. In the example I give, a underage user could sign up for a website to try and purchase something, but if it's restricted, the business model should look at the age that was supplied and go, no, you're too young, and not proceed with the transaction. Where and when to validate. Validation should occur not only on the client, but also on the server side. JavaScript input validation performed on the client can be bypassed by an attacker that disables JavaScript or uses a web proxy. Every pass through the trusted and less trusted boundary should be checked. And then the type of control is determined by the risk that the data may have on the application. So, if it's an area that has a high risk, then the type of control should be more restrictive to make sure that nothing inappropriate goes through. Improper data and integrity check. Missing or extra characters, which can violate a business rule or cause a buffer overflow. Wrong format, like dates not submitted correctly. I mentioned this before. You have day, month, or day, month, year versus month, day, year versus year, month, day, and so on. For example, if I gave you 11, 12, 9, which one's the day, which one's the month, and which one's the year? All of them could be used in any one of those combinations. Also, data outside acceptable range. Is a person 221 years old, or negative 80, for example, if they put in 2018 and then 2000, or they put in 18 minus and then without including the first two digits of the year, and then subtracting it out from another, and so you could get a negative number. Data with special characters. Some features use an apostrophe, which can't be blocked since last names use hyphens and apostrophes. There are also code executions that happen with using apostrophes, so you can't just blanketly eliminate them. Data can be the wrong type, like characters instead of numbers. Two different practices is blacklisting versus whitelisting. This technique allows for multiple types of testing, just as type, range, length, special characters, and so forth. Blacklisting, or also known as negative validation, checks for two issues. The list of criteria to avoid improper data is infinite and growing and leads to incomplete protections. Basically, trying to figure out everything that should be eliminated is a daunting task. System resources needed to check the blacklist can severely affect performance. Of course, the more things it has to check for every single input, the slower the system is going to run. Whitelisting, also known as positive validation checks, strongly typed at all times, length checked and field length minimized so that it is in the proper length and it does not, it uses just the amount of length it needs to. Range checked is if the values need to be between 2 and 100, is it within that 2 and 100? Unsigned unless required to be signed. More of a document sort of issue, but if something has to be certified or have a certificate and it's missing the certificate, then it should automatically reject it. And then syntax or grammar checked before first use or inspection. Basically to say, is something there that shouldn't be? Is there a character that might cause an issue? Possible exploits. There are SQL injects, which allow hackers to create, modify, or delete information in a database via engineered SQL query. LDAP injects is similar to SQL, except it works against the LDAP server. ORM injects works against, of course, ORM generated data access object models. XPath injects execute user controlled XPath queries. And then the cross-site scripting is used by hackers to create output that can allow various attacks, which help to steal information and allow hackers to control the browser. Possible exploits continued. Broken authentication and session management, when incorrectly implemented, can allow hackers to exploit passwords, keys, session tokens to impersonate another user. HTML injects XML documents into an application. Server-side injects code into HTML pages and allows for remote control code execution. And then the most obvious or most used would be buffer overflow, which is the predominant exploit where excessive data causes the application to react in different ways. It can either rewrite the value once it's filled, or it could go into another area of memory. And the two type of overflows are heap and stack that are included in that. Remediation. The main technique is checking data. That's sort of the obvious one, but by using whitelist works well with free-form text. It helps normalization of data into acceptable values, types, range, and so forth. Character category whitelisting, which allows various other global characters such as Arabic characters. Individual character whitelisting allows some special characters such as apostrophes and last names so that you can get a user to input O'Brien if that's their last name, or have a hyphen named like Major Dash Whiteford. Then checking input against business criteria allows for valid input to proceed and partially rejects suspicious input. It can't, of course, stop everything, but the object is to try and stop as much as possible without putting a drain on the system. Basic goals for input validation. Minimally be applied to all input. It really should be applied to all input. Define acceptable character sets, and then have a length requirements minimum to maximum. And here's a list of my references.